Microsoft provides best-in-class cloud services rooted in experience and innovation and powered by our platforms Windows Azure, Windows Server and System Center. As we enter each room, I'll provide a brief introduction. Use the in-scene hotspots, navigation and sensory feedback bar at the bottom of the screen to see more details. Get started. Find out how Microsoft ensures the security of your digital assets.
At a Microsoft data center, there are layers of what we call defense in-depth security, starting at the perimeter and continuing through every area of the facility to each physical server unit. Perimeter fencing, video cameras, security personnel, secure entrances, and real-time communications networks are in place to protect the physical assets and customer data housed within these facilities. We take security, privacy, and compliance seriously as we maintain and conform to the highest regulatory standards required to run our services globally. Now click the avatar and let's go inside.
One of the first things you notice when entering our server rooms is the sheer number of them. There are hundreds of thousands of servers in our facility in Quincy alone. From above the server racks, the networking cables travel from top-of-rack switches through the overhead yellow tubing, meeting at the aggregation point known as the interim distribution frame, which connects the server environment to the Internet. Microsoft is invested in creating one of the best connected networks on the planet, pairing with over 2,000 ISPs globally to reduce latency and ensure a fast and reliable experience for our customers. Take some time to look around the server room and then move on to explore the technology that keeps them cool.
It starts as a basic need. And through invention and innovation, it evolved into something larger than ourselves. A single light in a dark room becomes a daily miracle we don't think twice about. It's in our nature, it seems, to find a better way, a more efficient way, to free ourselves, and then forget. The more powerful the transformation, the more we take it for granted. We're already living in the dawn of the next great evolution. And we will shrug at the breadth of what lies behind the simple push of a button. Where weeks and months were once spent working bit by bit, it only takes Windows Azure's automated platform seconds. This place called the cloud, this place we all share, it doesn't exist in the sky. It lives in state-of-the-art Microsoft data centers around the world. Our world is evolving exponentially. In front of us, endless possibilities. Behind us, our ingenuity turned instantly ordinary. Innovation leads to opportunities, demanding more innovation, demanding we look forward, demanding we connect what came before with what lies ahead. This is our calling. This is what we do.
One of the areas with the greatest improvement is energy efficiency. We operate our data centers at a wider temperature range between 50 and 90 degrees Fahrenheit. Inside our data centers, on average it's 75 degrees Fahrenheit. Knowing that our servers can operate within a broader temperature range allowed us to approach power and cooling differently. There's only a select few places where we still need to run conventional cooling systems, like the chillers you see here. Later in the tour, you'll see how we use the concept of air, water, and humidity to keep our servers cool. These decisions result in extremely low energy consumption in our facilities and the right level of cooling for our servers. Our constant effort to lower costs is how we can deliver better, more affordable services. What you've seen thus far is what you'd expect to see in a more modern data center. But now it's time to show you the unexpected. In 2011, we stripped the data center down to its essence: computing, networking, storage, power, and of course software. The result? A modular data center, which represented a dramatic shift in the way we designed, built, and deployed data centers. Previous data center designs relied heavily on deploying servers by the rack to guarantee service availability. The modular data center design combines pre-manufactured systems, including integrated power and network connections, to deliver computing capacity faster. These pre-assembled components are essentially a data center in a box. We plug them into the power and network spine, light up the servers, lock them up, and walk away.
When you deploy to your own data centers, you typically have to accommodate your worst case kind of workloads, and that means that you're over provisioning the hardware for most cases, that a lot of hardware resources sit there idle. Plus, you're just buying for yourself, so you're paying for the kind of scale that you need. And whereas Microsoft, when we're building a large public cloud platform, we buy at massive scale. We let lots of people come and use it and take advantage of that lower prices that we get out of everything that comes with massive scale. In addition, we also can take advantage of over-provisioning that scale to even drive further costs out of the system and pass them on to you. So for example, if you only use hardware 50% of the time and we find another customer that can use it the other 50% of the time, we can pass that value along to you instead of having you pay for the 100%. One of the things that we see when enterprises are running their own data centers is they've got a lot of IT process behind allocating resources and getting those resources deployed. So you've got somebody in the marketing department that wants to deploy a marketing app, and so they get their line of business developers to go write the app. Then they've got to get IT resources to go even test the app. That means getting a server, provisioning it, getting it set up, integrated in the network and configured, and so on. That process actually, we see, takes anywhere between 6 weeks and 3 months in most enterprises. The value of the cloud and somebody else managing the infrastructure and having it there ready to go is that developer, the IT marketing department, can go in and literally within minutes get their line of business app deployed and up and running. So we definitely recognize that enterprises are going to be making a transition to the cloud over time, and that there's certain workloads where they'll be able to migrate those to the cloud before other workloads, even applications that might be split across the cloud and on-premise. For example, you've got some workload that has data that you want to keep in your data center or specific hardware requirements. So there's a number of different connectivity solutions that we're working on and already have in production that enables you to connect these applications together, from asynchronous messaging to secure private VPN channels between your on-premise network and the cloud network, to being able to take your identities and synchronize them with Office 365's identity system for use from the cloud. One of our biggest steps, we've just recently made that step, is to introduce infrastructure as a service as one of the offerings, which lets you take off a server running your legacy applications, lift them up and put them up into the cloud, and make that migration at your own pace of taking that server, this infrastructure legacy, and starting to migrate it to adopt more platform as a service functionality to take advantage of the features that gives you. One of the things that we're starting to look at is how do we make disaster recovery and high availability and geoscale available and easy to customers that are writing applications to deploy in Windows Azure. You can see one of our first steps in that direction with Windows Azure Storage, where a while back we started to we introduced geo-replication, asynchronous replication of storage data from one data center to another one in the paired geographic region, for example, north central U.S. to south central U.S. But over the next few years, you're going to see us introduce platform as a service application concepts that will make it easy for somebody to create an application and with a simple checkbox say, yes, I'd like this to be made disaster recovery aware, highly available, so if it fails the data center or my access to the data center, customer access to the data center fails, that I can have it moved to a different data center.
When I think of cloud scale operations and how we manage and build for that kind of an ecosystem, the thing we're always looking to do is how can we be more agile? How do we grow? How do we deal with the complexity when you start dealing with the scale at which we're growing? Generally speaking, we try to simplify. We try to integrate a lot of the complexity away. When you take traditional data centers, they tend to optimize for resiliency by adding more infrastructure and adding more complexity into the system. Whereas on cloud scale perspective, the resiliency is moving into the software and the hardware is just simplified. And when I speak about hardware, I'm speaking about the data center infrastructure, the server infrastructure, and so on. So it's really looking at the whole thing and how we integrate across the whole stack, optimize for the lowest possible cost, yet providing the best customer experience at the end of the day. We're already within our own environment. We're building data centers now that no longer have generator backup, for example, because the resiliency has moved into the application. That's a huge savings from a cost perspective. It also does a lot in terms of some concerns around the environment, and this has been something we've started already a couple of years ago, and we see it playing a bigger and bigger role in some of our future data center designs. When I was thinking about the term that we've coined now, the data plant within Microsoft, I looked at the parallels between power generation, the utility industry, and then also the data center industry, and how closely tied we are in terms of the things we can do to work together and to integrate and simplify the ecosystem. And so one of the things we've been doing now here at Microsoft is actually making that concept from a few years ago a reality by essentially taking the data center right to where power is generated. As a result, we've substantially simplified the ecosystem by this integration where we've eliminated the need for power grid, high voltage, and we can simplify everything, substantially bring the cost down, and create essentially what now generates data. If I look at what we've done in the 5 or so years I've been here, initially we talked about how servers could operate at much broader temperatures. This was about 5 years ago. And how we should be using more outside air and less conditioning and so on. And if you look at what the industry is doing, it's now become mainstream. So that's been a great success. What gets me excited is that through this massive integration, we will be able to drive costs an order of magnitude lower because we will have optimized from power generation all the way up the stack to the application. And this is something that can only be done at scale and something that you can never do at the scale of an enterprise. And as a result, I think CTOs will be looking at this in the future and thinking about how can they leverage this substantially lower cost computing infrastructure in the future.
Microsoft has invested more than $15 billion in a globally distributed cloud infrastructure that is scalable, reliable, secure, and efficient. We've invested $9.5 billion in research and development to grow our capacity, while continually improving operational processes. Every day, we run more than 200 global cloud services and process trillions of transactions for billions of people, and those numbers are growing exponentially. So what's next for Microsoft's data centers? We will continue to learn from our experience, invest in our network, refine our cloud server design, and innovate in our cloud services platform Microsoft Azure so that we can lower costs and attain our goal of having a net zero carbon footprint. All of this is so that we can better serve our customers, allowing you to not worry about escalating costs or increasing complexity and to pursue vast possibilities.